Hi, this is Miss Marion. We are starting Unit 8. We're doing Lesson 1 and 2 today, but right now we're going to go ahead and start with a starter to kind of remind us how to go ahead and solve equations, okay? So get out a piece of paper. Let's go ahead and solve these. So pause and solve these, and then come back to me. All right, so the first thing we want to go ahead and do is we want to combine like terms together. So we're going to have negative 4 minus 6. Negative 4 minus 6 is negative 10. X, and then we have negative 20, x. Negative 10 and x, they are multiplying each other, so we are going to divide by negative 10 on both sides. Negative 20 divided by negative 10 is a positive 2. We'll equal our x because negative 10 divided by negative 10 is a 1, and we cross those out. Moving on to number 2. So right now, there's nothing that we can combine together on either side. I like to go ahead and take all of my variables and put them on the left-hand side. So I'm going to move my positive 7x. Because it's positive, I'm going to put negatives with it to make it a 0. 8x minus 7x is 1x minus 2 equals a negative 9. And then we want all variables on one side and numbers on the other. So we're going to add 2 to both sides. So then we have 1x equals negative 9 plus 2 is negative 7. So x, or 1x, equals negative 7. All right, so let's go ahead and put all numbers on one side, letters on the other, but we have to remember we want to pull from the crowded side. So the left-hand side is crowded, and it's a positive 4m. So we are going to, we can subtract off 4m, but also notice how there's a positive 4m and a positive 4m, so our variables are the same. But are numbers the same? No. Technically, it's like plus 0. So if our variables are the same, numbers are different. Remember, this is no solution. Okay. All right, number 4. So remember, when we have a negative on the outside of our parentheses, it's technically negative 1. And we're going to multiply a negative 1 into our parentheses. So we have negative 1 times x is negative 1x, plus negative 1 times 4 is negative 4, and we still have that negative x on the left-hand side. So now what we want to do, again, we want to put all numbers on one side, letters on the other. So I'm going to go ahead and I'm going to move the negative 4 wants to be with the negative x on the other side. So I'm going to add 4 to both sides. So I'm going to have negative 1x, positive negative 4s. They make a 0. Negative 8 plus 4. Put it in your calculator exactly how it looks. So negative 8 plus 4 is negative 4. And then now we still have a negative 1x, negative 1 multiplied by x. So we're going to divide by negative 1. So negative 1 divided by negative 1, we cross them out, it makes a 1, crosses out. Negative 4 divided by negative 1 is a positive 4. All right, last one. Again, we have a negative 1. On the outside, negative 1 times p is negative 1p. Subtract. Negative 1 times 8 is negative 8. Minus a negative, remember, is the same as adding, right? So then we're going to subtract off 8 on both sides. We get negative 1p. 14 minus 8. Let's kind of think about it. 14. Put it in your calculator exactly how it looks. 14 minus 8. That is 6. And again, we still have negative 1 multiplied by p. So we're going to divide by negative 1. So then we're going to have p equals negative 6. Awesome. Hopefully you got those. Solving equations is one of our main things that we need to learn in 8th grade. So make sure you understand and know how to do this. All right, so let's go ahead and turn to page 131 in our workbook. If you have not gotten your Unit 8 workbook, make sure you either get one in class if you're with me, or if you're online, make sure you go to the attendance office, tell them your name, and they'll give you a unit workbook, Unit 8. And let's read the I can statements for both Lesson 1 and 2. So Lesson 1 is, I can find the area of a tilted square on a grid by using method like decomposing and rearranging, and surround and subtract. And then I can find the area of a triangle. So go ahead and give yourself a sentence about that, and also a number. So 1, I don't remember. 2, I kind of remember it. 3, I do remember it. And then 4, I can teach it to my friend. And then, as I said before, we're going to go ahead and read lesson 2. Lesson 2, I understand the meaning of expression like that is square root of 25 and the square root of 3. If I know the area of a square, I can express its side lengths using square root notation, and I can explain what a square root is. Again, give yourself a sentence about how you feel about these, and then also a number. So 1, I don't remember. 2, I kind of remember it. 3, I do remember it. And 4, I can teach it to my friend. All right, let's turn back to page 7. It says, what shaded region is larger? Explain your reasoning. So I kind of gave you a sentence frame. I believe that blank figure is larger because blank. So go ahead and pause, figure that out, and then come back to me. All right, so let's go ahead and look at this. So figure A. So if you think about different regions on different things, we can kind of take things together and count how many squares we have. So I can look at this triangle and I can kind of flip it down so it comes into here. So this is like 1. And then I can take this triangle, flip it down here. Here's 2 triangles. And then I can kind of do the same thing. I can take this triangle, flip it up. That'll be 3. This triangle here, flip it up. 4. So figure A has 4 squares. Let's kind of do the same thing with figure B. So I'm going to go ahead and I'm going to take this triangle, flip it down. Here's triangle number 1. Okay. And then I can take this triangle, flip it here. Here is 2. And then take this triangle, flip it up. Here's 3. Take this triangle, flip it down. Here is 4. And then we have 5. So figure B is actually larger because it has 5 squares instead of 4 squares. All right, let's look at page 7 is where we're going to start. But then we're going to go into page 8. And it says, find the area of each shaded square. And the units will be square units. Because we're just talking about squares. So go ahead and pause, figure that out, and then come back to me. All right, so let's kind of work through this. The way I like to do it is I like to find the area of the bigger square, if that makes sense. So like this one. And then I like to go ahead and subtract off the 4 triangles. So let's look at the bigger square. So there's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So there's 10 squares on one side. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 on the other. So 10 times 10 is 100. So that's the area of all of it. And then let's look at the triangles. So remember that the area of a triangle is 1/2 the base times height. And so if we look at our triangle, we have this is our base. So 1, 2, 3, 4, 5, 6, 7, 8, 9. Height is 1. So the area of the triangle is 1/2 times 9 times 1. So let's go ahead and grab our calculator and let's go ahead and do 1/2 times 9 times 1, which is 4.5. So each of these triangles is 4.5. And how many of them do we have? We have 4 of them. So the total of all the triangles is 4.5 added up 4 times. Which is 18. And then to be able to find the blue tilted square, we're going to have 100. We're going to minus off that 18. So 100 minus 18 is 82 squares. And that's our blue triangle. All right, number 2, again, find the area of the shaded square, and it will be square units. All right, same thing that we kind of did before. So we're going to have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So we have 10 on one side. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 on the other. So the bigger square is 100 because it's 10 times 10, area of the square. And then again, we're going to subtract off the area of the triangles. So if we look at the triangle, let's do that in red. So we have our length, our base. So 1, 2, 3, 4, 5 times our height. 2, 3, 4, 5. So we're going to have 1/2 base times height. So 1/2 times 5 times 5, which is 12.5. So all of these are 12.5. Let's go ahead and add 12.5 4 times. Which is 50. So we're going to subtract off our 50. And the area of the blue shaded is 50 square units. All right, let's go ahead and figure out number 3. So this is without a grid, so we can't really count them, but we also have numbers here, right? So again, we're going to do the area of the bigger square minus off our triangles. So let's go ahead and the sides, if we do 7 plus 3 is 10. 10, okay? And then our area is 1/2. 7 times 3. So let's do that. 1/2 times 7 times 3. It's 10.5. And then we're going to have 10.5 added together 4 times, which is 42. The bigger square is 100. So we're going to have 100 minus 42, which is the tilted blue square, which is 58 square units. So this kind of helps us understand as far as decomposing or rearranging different triangles and be able to go ahead and find the bigger triangle versus that smaller triangle. All right, let's go ahead and turn to page 11, 10 and 11. And we're going to go ahead and work at different squares themselves. So we have A, B, and C. It says, what is the side length of square A? And then what is its area? Number 2, what is the side length of C? And what is its area? And then what is the area of square B? What is its side length? And if we need to, we can use tracing paper if we need to, or just a piece of paper to go ahead and do that. So let's go ahead and pause, answer all 3 of those questions, and then come back to me. All right, A, let's look at A first, right? So A is 1, 2, 3, 4, 5, has a length of 5, area of 25, okay? C, 1, 2, 3, 4, 5, 6, 1, 2, 3, 4, 5, 6, 6 times 6 is 36. So the sides are units, just units, and the area is square units. Let's go ahead and label those, make sure we have all those. 36 square units. Awesome. All right, so with B, what I'm going to do is I'm going to find the area of B first, kind of like how we did before. I'm going to make that bigger square. Okay, so the green is 1, 2, 3, 4, 5, 6, 7. Okay, the area is 1, 2, 3 by 1, 2, 3, 4. So the area of the triangle is going to be 1/2 times 3 times 4. Let's go ahead and do that. So 1/2, 3 times 4, and we're going to have 6 is the area of the triangles, and we have 4 of them, okay? So the area of the big triangle, or sorry, the big square is 7 times 7, which is 49, okay? Then we're going to subtract off 4 triangles, which is 6. So 4 times 6 is 24. So 49 minus 24 is 25. So the area of B is 25 square units. Maybe I should actually change. Let's erase some stuff. Let's change the color. So 25 square units. Okay? Now let's think about it. So to find the area of the square, so the square B, like the red stuff, right? It's going to be length times width. And with a square, they're both the same. So really, what number multiplied by itself makes 25? So that is 5. So the length of of B is 5 units, and the area is 25 square units. Okay, if you did not understand that, go ahead and pause, rewind that, and go through it again, okay? So now let's kind of do the same thing with D, E, and F. Let's find the area of square D, E, and F, and which of the squares must have a side length that is greater than 5 but less than 6, okay? So go ahead and work through that. So pause, work through that, and then come back to me. All right, as you can see, I went ahead and drew the extra square on the outside, found the 4 triangles within D, E, and F, and went ahead and kind of subtracted off. So let's kind of look at it. So if we have it, so we have 6 times 6, which is 36. The area is 1/2 4 times 2, which is 4. So I have 4 triangles that are at 4, so 36 minus 16, which is 20 square units, and that's for D. E is 7 times 7, which is 49. The area of the triangle is 1/2 times 5 times 2, which is 5, and there's 4 of them, so that's 20. So 49 minus 20 is 29 square units. And with F, we have 8 times 8, and then the triangle is 1/2 times 3 times 5, which is 7.5. So we have 8 times 8 minus 7.5 times 4, because there's 4 triangles. 64 minus 30 is 34 square units. So these are the areas of D, E, and F. Now let's think about it. It asks, which of the side lengths is greater than 5 but less than 6? Okay. So to find this one, we have 20. So you have to think of a number, multiply by itself would make 20. This one's actually going to be less than 5, because 5 times 5 is 25, but this one is 20. So this one is going to be greater than 5, but it's also less than 6, because if we had it, the side was 6 times 6, it would be 36. So this is in between 25 and 36. So the side of the black triangle is going to be in between 5 and 6. Let's look at F. 34. So again, 34 is in between 25 and 36. So this one is also the side of the black triangle, or sorry, the black square is between 5 and 6. So if we have a square, we can go ahead and figure out the side lengths. We can also figure out the triangles that are in there. We can go ahead and figure out the tilted square itself also. So let's go ahead and turn to page 17. On page 17, we have this picture. So I need you to write down one thing that you notice, and then one thing that you wonder, and then come back to me. All right, some things that we can notice. We have 2 circles intersecting. There's a triangle in there. We have 2 different colored circles. We have segments, AB, BC, and CA. They're also different. Some things that we can wonder is, why is it colored this way? Is BC a radius of one of the circles is the radius of both circles. Okay. And then why are we doing this? Why do we have this diagram? And we're going to answer a lot of that kind of stuff in our next activities. All right, so let's go ahead and turn to page 17. On page 17, it says, use the circle to estimate the area of the square shown here. So go ahead and pause, answer that question, and then come back to me. So I noticed that if we look at it, we have different radius, or radii, right? And notice how the radius is probably somewhere about 5.25. Because we can also look at the radius this way, right? And this one over here is also 5.25. So let's find the area of the square that's on there. It's kind of drawn a little weird, but let's do 5.25 times 5.25. And this area is about 28. So it's 27.56. So we can say about 28 square units. All right, so let's go ahead and look at number 2. Now it's on a grid. We can look at the grid a little bit further and kind of see what's going on. And let's go ahead and figure out the area. So use the grid to check our answer of the first one and then come back to me. All right, so notice how I went ahead and I drew that bigger square, right? And then I found that bigger square, the sides are 7, so it's 7 times 7, which is 49. Now let's go ahead and let's figure out that triangle. So our triangle, remember the area of a triangle is 1/2 the base, so 1, 2, 3, 4, 5, times the height, which is 2. So we're going to have 1/2 times 5 times 2, which is 5. And again, we have 4 of those triangles. So we're going to have 4 times 5. 4 times 5 is 20. So 49 minus 20 is 29 square units. So our original, the one that we kind of guessed on, is almost what we said it was about 28. It's actually 29. So notice how we can go ahead and we can use different circles to go ahead and find those squares. We can also put it on the grid and we can make a really good estimation as far as what's going on with these. All right, so let's look at number 1. So it says find the area of each square and estimate the side lengths using your geometry toolkit, and then write the exact length of the square. So go ahead and pause, and we're going to do number 1. So it's A, B, and C. All right, so for square A, you should have 29 square units, and you can kind of see how I went ahead and found that. For B, I had 18 square units, and then for C, I had 13 square units. So these are all the areas for A, B, and C. If you need to pause and kind of look at what I did, but it's what we've been doing before. We make the bigger square, we find that area, and then we subtract off the 4 triangles areas. Now what I want you to do is I want you to go ahead and to complete the table. So notice how it says side length is 0.5. What would be the area? So if I had a side length of 0.5 as my square, how would you find the area? I would do 0.5 times 0.5, which is 0.25. And then look at it. If I had an area of 4, I have to think about it. What number multiplied by itself would make 4 for the area? Oh, that would be 2. So go ahead, pause, and fill in this table, and then come back to me. All right, so this is the table that you should have filled in with the different numbers. We did the 0.5 and the 0.25. One thing I want to kind of point out here is notice how we have, if the area is 4, we have to think, okay, what number multiplied by itself would make 4? Oh, that's 2. And then here's 9. What number multiplied by itself makes 9? Oh, that's 3. So notice how we kind of got those numbers kind of going back and forth as far as here's the side length and then here's an area. The next thing I want you to do is I want you to take this whole table and I want you to plot the points on the graph and kind of see what happens, see what's going on along with there. So this is the graph that you should have gotten. Notice how the graph is not linear, it's kind of curved, right? So linear, straight, this is really not a straight line, and it kind of goes along with it. and notice how we can kind of see different things where we have the side lengths here, and then we have the area, and we can kind of look at, oh, well, yeah, if I have a side length of 4, my area is going to be 16, okay? So notice those different things along with this. All right, so number 4 on page 22, I use the graph to estimate the side lengths of the squares in the first question. So I went ahead and I put the picture down there. So we have 29 square units as A, 18 square units as B, and then 13 square units as C. So let's go ahead and figure out what those sides will be, and then come back to me. So what we're going to do is we're going to use this graph, but we're going to use it backwards. So 29 is about here. So, and remember how we kind of found these numbers is like if 2, so 2 multiplied by 2 is 4, and then 4 multiplied by 4 is 16. So now I'm kind of do it backwards. So I have 29 is going to be somewhere in this area. So it's going to be probably around a little bit bigger than 5, right? And so the way that we kind of think about this is we're actually going to be talking about the side length. To be able to find the side length is that we're going to do the square root of 29. And the square root kind of tells us, okay, what number multiplied by itself would make 29, okay? Kind of the same thing with B. Looking at B, 18, so 18 is about here. So this number is going to be a little bit bigger than 4, so it's going to be 4 and a decimal. And again, we can kind of say our side length is going to be the square root of 18. And then C, the same thing, our side length is going to be the square root of 13. So this is kind of like the actual amount. We can actually put these in our calculator and find the square root. In fact, if you do second and then x squared is kind of how it is in a lot of the calculators. It has 5.385164807. So this is an approximation, but the square root of 29, or the side length that if we multiply it by itself would make 29, is about 5.39 is what that number is. To find the actual, we would write it just as the square root of. We would write it just like this, or we can put it into our calculator and we can find that decimal that goes along with it. So it says use the graph to approximate to the square root of 45. So go ahead and pause, answer that question, and then come back to me. So again, let's go ahead and use this graph. So 45 is up here. So it's going to be a number between about 6 and 7, okay? So more of like 6.5 and 7 as far as the square root of 45. So today we've been talking about side lengths of squares. So if we do a length times like a side times a side, it makes us like the area of a square. And then we can also do that backwards as far as if we have that area, if we take the square root of it, or if we think about, okay, what number multiplied by itself would make that area, then we can find our side length. So they kind of go together hand in hand. So let's go ahead and turn to page 131. It says, I can find the area of a tilted square on a grid by using the methods of decomposing and rearranging or surround and subtract. And then we can find the area of a triangle. Go to write a sentence about how now you feel about it. Give yourself a number. So 1, I'm still confused. 2, I kind of got it. 3, I did get it. And then 4, I can teach it to my friend. And then go ahead and read lesson 2. So I understand the meaning of an expression like the square root of 25 and the square root of 3. And if I know the area of a square, I can express its side length using the square root. Kind of like what we just barely did. The square root of 29 is the side length of an area of 29. And then I can explain what a square root is. And then give yourself a sentence about how you feel about these. A number, so 1, I'm still confused. 2, I kind of got it. 3, I did get it. And then 4, I can teach it to my friend. So again, because we went over 2 lessons for today, we are doing 2 practice problems. Those are on Canvas, and make sure you get those done. And then if you have any questions, you can go ahead and email me at any time. Hope you have a good day. Thanks. Bye.